Now, let's have some the commonly calculation included in calorimetry. First one, we have the enthalpy, which is a state function. It is a type of chemical energy sometimes referred to as heat content. A change in enthalpy does not depend on the pathway between two states. The enthalpy H, which is equivalent to E plus PB, wherein E is the internal energy, P is the pressure, and V is the volume of the system. To calculate for the enthalpy, it is equal to Q sub P, which is at constant pressure where only Vp work is allowed, the change in enthalpy H of the system is equal to the energy flow as heat. This means that for a reaction studied at constant pressure, the flow of heat is a measure of the change in enthalpy for the system. For a chemical reaction, the enthalpy changes is given by the equation delta H equal to H product minus H reactants. At constant pressure, exothermic means, we will discuss later, delta H is negative, and for endothermic means, delta H is positive. Second, we have the internal energy or E. It can be defined most precisely as a sum of the kinetic and potential energies of all the particles in the system. The internal energy of a system can be changed by a flow of work, heat, or both. That is, delta E, or change in internal energy, is equal to Q plus W, where Q is the heat, represent the heat, and W represent work, wherein work is equivalent to force times distance. And we also know that force is equivalent to pressure times area. And as we multiply area with the distance or on height or altitude, we can get the value for the change in volume. That's why work is also equal with pressure times change in volume. So work is negative for an expanding gas, meaning the volume is increases. And the work is positive when gas is compressed, meaning the volume is decreases. Lastly, we have the heat capacity. Heat capacity of a substance, which is measured of this property, is defined as C equal to heat absorbed over increase in temperature. When an element or a compound is heated, the energy required will depend on the amount of the substance present. Thus, in defining the heat capacity of substance, the amount of substance must be specified. If the heat capacity is given per gram of substance, it is called the specific heat capacity, and its units are joule per degree Celsius times gram, or joule per kilogram. If the heat capacity is given per mole of the substance, it is called the molar heat capacity, and it has the units J over degree Celsius, mole, or joule per kilomole. Sorry, K stands for Kelvin. So I repeat, for specific heat capacity, the units is joule per degree Celsius gram or joule per Kelvin gram. And for molar heat capacity, the unit is joule per degree Celsius mole or joule per Kelvin mole, wherein Kelvin is the standard unit for temperature. Now, let's check your understanding. Try to answer this problem and write your answer in the comment section.